Okay, so if you look here, when we stripped the insulation off the end, which was already done for us, of the pink and the white part, we saw the copper. I told you a minute ago that those the color of the copper and what we saw was just individual atoms of copper. So it wasn't copper and something else. It was just copper. So that's how we make copper. It's just a bunch of atoms of copper. We couldn't see individual atoms though. Now, what you may not know, but you may actually know this and not remember. Have you ever heard someone say, "Oh, give me some H2O"?
H2O is water.
Yeah, H2O is water. So H2O is actually what tells you that water is made of molecules. The H stands for hydrogen and the O stands for oxygen. And this is very beginning chemistry here. But when you take the oxygen atoms and link them with 2, that's why there's an H2, of the hydrogen atoms, you get an H2O or a water molecule. So what you did, you see there, the red represents the oxygen and then the little gray circles represent hydrogen. So you can see how at first it was just 2 hydrogens and an oxygen. And then when you bond them or link them together, you get a water molecule. So you have there 3 atoms making a water molecule. 2 of the atoms are the same thing, and 1 atom is just by itself, oxygen. Okay, so what you did was you placed the wires in the water, and electricity began flowing through the water, okay? So the energy broke down water molecules. So they were bonded and linked together to make a molecule of water. But the electricity disturbed that and separated them out. So where you saw the bubbles, that was actually hydrogen and oxygen gas bubbling, because they were then becoming gases. They were no longer actually making a water molecule in that area. There was water molecules still in the water, but in that reaction area with the wire, they were being broken down. So that is why when you pulled out the wires, the wire that was connected to the positive terminal of the battery had the bluish green color, because it was receiving the electricity. You had to have the electricity to break up the water molecules to cause the hydrogen and the oxygen to then react with the copper. So you know that water is made up of hydrogen and oxygen, but you also remember had what? The sodium bicarbonate. So sodium bicarbonate was also in there as well. So what we're going to see here is we took copper and we made the blue-green substance that we see on statues and things like that called copper hydroxycarbonate. You don't have to understand how that made that name, how you took all we did, but basically you can kind of guess. We know we had copper. The hydroxy part could have come from the hydrogen from the water, hydroxy, and the carbonate, remember we said the baking soda was called sodium bicarbonate. So you can kind of say, oh, like this sounds familiar. We took like 3 things and made something else. So what we're learning here is that atoms link together to make a molecule, but also we're learning that they can, the molecules can be broken down and then linked to other things as well, because we broke down the molecule of water, okay? So what we saw, and I almost said it a minute ago when we were doing the lab, but I was going to kind of wait and introduce the word. What we saw was what's called a chemical reaction. And it's easy to remember reaction because you were able to visibly see the bubbles and you knew something was happening. Okay, so now we just have to go over a few terms. And these are things that, like I said, you may not have heard before. Just kind of put them in the back of your mind because you're going to hear them throughout the year. An element is just something that it is. And what I mean by that is copper is an element. It's just copper. Like it's not anything else. It's only made of atoms of copper. So elements are when they are only made up of their own atom, okay? So if you have oxygen, it's an element. Now, have you ever seen this big chart called the periodic table of elements?
Yeah.
Okay, so it looks very confusing. We're not going to do a whole lot with it this year. In chemistry, you'll really see it. But all of those little squares on that chart are elements, and they're just their own item. They're just what they are. So copper is just an element. A compound is when you take billions of molecules and you make something. So for example, salt or water. So the molecule of water actually is telling us that it's now a compound. We took elements, hydrogen and oxygen, to make the compound. So element, element, compound. Just like 2 + 2 = 4.
Yeah.
The compound is what you get at the equals part. Now, some things are not a compound. So, like wood, plastic, they're just called mixtures because they're not really just like 2 or 3 elements linked together. They have lots of different things in them. Do you know what we call salt? Have you ever heard anybody call salt sodium chloride? Yeah, or NaCl. Like sometimes you just realize you've seen things over the years and you didn't really know what you were seeing. But that's because sodium is on that periodic chart of elements, and so is chloride. Those are elements. And when you took those 2 elements and you combined them to make the compound salt, you had a chemical reaction and you took 2 things to make salt or a compound. Okay, so this is just something, this won't be on a test, but I want you to just kind of be aware of this. Some people will say that we can see atoms, and there's something called a scanning tunneling electron microscope, which is very fancy. But basically, that microscope just uses computer calculations and adds color. And if all of the circumstances that the microscope is using, any calculations or theories are completely correct, then we can kind of see a representation of what an atom would look like from that microscope. But it still does not mean that we're like seeing the true atom with the naked eye. It's just a way to try to help us visualize what an atom would look like. Okay, so we're going to kind of fast forward real quick to, well, I hate to say it, but there's a little bit of math and science. Did you know that?
Yeah.
Miss Loper said every time that she announces that there's a little bit of math and science, people want to go running. So Miss Loper and I were talking, she's the teacher next door, and I was telling her that I don't love science. I mean, I don't love math. I do love science, but I don't love math. And she's like, oh, well, you should tell your students you don't love math. And I'm not saying that you don't need math. You do. We all need math. I use it every single day. I just am not wonderful at math. It doesn't come easy to me. So we are going to use some math in science, but it's not going to be scary. And if I can do it, you can do it. And we're also going to allow you to use calculators when we do math and science. So if you have a calculator, you're welcome to bring that. When we work things in class, I'll have a calculator. But if I assign you something at home that uses some math, you can use your calculator. Okay? All right, so we're going to talk about a few things to just get us started with the way that math works in science. And the first thing we need to talk about is units. Okay? And what I mean by units is, if you said, oh, Dr. Mitchell, how tall are you? If I just said, well, let's see. If you said, how tall are you in centimeters? I'm not even sure how tall I am in centimeters, but let's just go with something random. If I said 72, then you would be like, oh, centimeters. But do you ever hear people say they're 72 centimeters?
Mm-hmm.
People usually say, oh, I'm 5'7". And we just know that means 5 feet 7 inches. Yes. But if you said, how long is that table? And I was like, 3. You would be like, waiting. Like, what comes after that? You have to have units or something that tells us how you measured it. So did you measure it in feet? Did you measure inches, pounds, grams? So whenever we report numbers, and this does matter on tests, you have to give me a unit. So if I give you a problem to solve and it is something that uses some math, and at the end you just say 7, then I'm either going to give you no credit, depending on how the problem was, or partial credit. So make sure you always give a unit with your number. Okay, so we're going to use what's called the metric system. You don't have to get really tied up into what that means. It's just if someone says to you, metric system, I want you to know that that is what we use in science. Scientists just use it across the board. But what does matter is the units we will use in science, okay? And some of this you may have heard of, some of you may not have. So let's just go through them kind of quickly because we're just going to give an overview today. You'll see it come up a lot more later. Okay, so if I said, what is an object's mass? Mass. That means how much matter is in that object. Everything is made up of matter. You've probably heard that in general science. The way we measure mass in science, which is the metric system, is in grams. A paper clip weighs about a gram, okay? So when you talk about weight, which is what you and I would talk about, I'm never going to come up to you and say, what's your mass, Brad? If the doctor says, how big are you? He's going to want to know your weight. Weight is different. Weight has to do with how gravity is pulling on us. So your weight changes based on your location. If you went to the moon, have you seen people when they walk on the moon, they're not like sticking down, right? The pull of gravity is different. Your weight on the moon is different than your weight here on Earth, but your mass doesn't change. You don't lose substance that your body's made of. You don't lose that when you go to the moon. All that changes is the gravity. Okay? So weight and mass are different, and so you need to remember that. They're not the same thing. But we use typically pounds. We use what's called the English system. And America is like, we're one of the only ones that still do this. Most places use the metric system. I thought this was crazy. I actually didn't know this because we don't use it, but mass in the English system is measured in the slug. I've had lots of school and I've never heard anything measured in the slug, but I just had to put that out there in case you ever see it. But I have heard of people using Newton. The unit for weight in science is Newton. It's really only in science. We never talk about a person's weight or like the weight of a car in newtons, okay? But we will use it in science. It'll make more sense as we get going further. Of course, distance, we usually use feet. Like walk 6 feet over and perform this task. Meter is what we will use in science. That's the metric system, okay? Have you ever seen a meter stick? Okay. It's you saw them all the time. People use them in sewing and things like that. Volume is how much space an object occupies. And you probably are familiar with gallons, like a gallon of milk. But you may also be familiar with the unit for volume for science, which is liter. Because when you go get like a big bottle of Coke or Sprite, those are 2 liters. Yeah. So we see liters and gallons both. We also will have time that we talk about in science. And time has to do with our chemical reactions. Like a minute ago, I said minutes. Like, let's wait 10 minutes. So you will hear us measure time or seconds. We usually use seconds because most things happen pretty quickly in science. But you, of course, could go back and forth with that. And we'll talk about that next week. Like if someone gave you seconds, you could turn that into minutes because 60 seconds is in a minute. So if someone said, oh, it took 90 seconds for the reaction to occur, that would be the same thing as a minute and 30 seconds. So we're going to talk some more about that next week, what's called converting. Converting just means swapping from unit to unit, okay? And like I said, the first few weeks of this are going to be really new, and I'm going to be very patient with you and help walk you through all of it. So what we're going to do right now is we're going to talk about doing a lab report, because that's your homework this week. And then you are going to have an atoms and molecules worksheet. I may have a copy today to give to you. If not, I'll just send it through email tomorrow. You'll get the day after class on Fridays, you'll get your next week's assignments and any handouts that you need. And then you'll be reading the next 10 pages of this chapter, which is we'll be finishing out Module 1 or Chapter 1 for this week. But first I'm going to use the board, and we're going to talk about how to get your lab report started so when you're at home, you'll know how to go back over that. Okay. All right. Let me get this turned off. Now, I can't remember if I gave you a blank lab report. Do you remember? Did you print that and bring that with you?